Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 10 of lesson number 11, Work and Energy. So as in the last class we started with potential, we completed about the kinetic energy, and we even started with respect to potential energy, right? Today we need to discuss about potential energy, like what will happen if the potential energy is at height. So this we have already discussed in short, that if the potential energy is like the stored object is at height, it's going to have more kinetic energy, right? So we will be discussing about that in detail, and then after that we have conservation of energy to discuss in detail, where we will be deriving the like uh, equation for conservation of energy, that is total energy is equal to kinetic energy plus potential energy, right? So we'll be deriving that. Then after that we have like rate of doing work, we have one more concept in between. Okay, so this is what we are going to discuss in the lesson, and as you know, there are like many activities and you can say examples which have been given for each and every concept, and mostly they have given more examples and activities with respect to potential energy, right? So I want each one of you to please go through it quickly, and then I'll proceed with this part where we will be continuing with the further part with respect to potential energy. Okay, but please be quick everyone. I hope every one of you have started revising it. So we started with the term work over here, and in detail we discussed on that not much work in spite of working hard, right? So I want each one of you to please go through it quickly. Then we discussed on this activity 11.1. So I want each one of you to please go through it quickly. After this, we discussed on the scientific conception of work. So I want you all to please go through it, everyone. I hope every one of you are going through it. After this, we discussed on this activity 11.2. So I want you all to please go through it quickly. I hope you all are going through it. After this, we discussed on this activity 11.3. So I want you all to please go through it as well, everyone. Then we discussed on the work done by a constant force. So I want each one of you to please go through it quickly. Then we discussed on this example 11.1. I want each one of you to please go through it quickly. So here we have the brief explanation on it, and I want you all to please go through it quickly. Then we discussed on this activity 11.4. So I want each one of you to please go through it quickly. Then after this we discussed on this example 11.2. So I want you all to quickly go through this as well, everyone. After this example, we discussed on what exactly energy is, right? So I want you all to please go through this as well, everyone, cause like this is the start of the energy, right? So please go through it because here we have many examples which have been given. And after this, we discussed on the forms of energy and everything. So before that, you should be knowing the basics, and I hope you're clear with it. So you should now come up with the examples on your own. Not the same examples, but the other examples. Okay. After this, we discussed more about work where we have the exact definition for that and the units which have been used to express it. Everything has been given, right? So please go through it, everyone. After this, we discussed on this activity 11.5, and I want each one of you to please go through it quickly. Then we discussed on the forms of energy. Now you might be knowing these forms of energy like very easily, because like you don't have to explain them in detail. It's just that you need to know which are the different forms of energy which are available around us, right? So I want you all to please go through it. Then after this we discussed on like James Prescott Joule, who was a British physicist, because like the unit that we use for energy and work is been named after him, right? So over here we have the, you can say, inventions that he came up with and everything, right? So please go through it. Then after that we started discussing on kinetic energy, where we have like even discussed on the derivation for it, right? So over here we have many different examples which have been given, and I want you all to please go through it. So over here we have the kinetic energy, the derivation for it, and we know that kinetic energy has been expressed as half mv square. And for deriving this half mv square, we need to know two different formulas. One formula is v square minus u square is equal to 2as, and the other formula that we have is like for work, which is equal to F into S, or like we even say that's M into A, right? M in F into S. So we know that force is equal to M into A, and S is equal to V square minus U square upon 2A. So according to that, we need to go. Okay. After this derivation, we discussed on like when can we say that it has kinetic energy, or it has like there's no kinetic energy in it, right? So for that, we have like if it's stationary, in that case we say that it doesn't have any kinetic energy, right? But if it's moving, if the object is moving, then in that case it has kinetic energy in it. Then we discussed on this activity 11.6, and I want each one of you to please go through it quickly. Then after this we discussed on this example 11.7, and I want you all to please go through it quickly as well. Then we discussed on this example 11.3, and I want you all to please go through it as well. Then we even discussed on this example 11.4, and I want you all to please go through it quickly as well. Then we started discussing about potential energy, and I hope every one of you are going through it. Then we discussed on this activity 11.8. So I want you all to please go through it quickly. Then we even discussed on this activity 11.9. So please go through it as well. Then we discussed on this activity 11.10. So please go through it quickly, everyone. Then we even discussed on this activity 11.11. So please go through it, everyone. Then after this, we discussed on this activity 11.12. So please go through this as well, everyone. So now we need to discuss potential energy of an object at a height. So for that, see, an object increases its energy when raised through a height. When will it increase its energy? When we raise it through a height. And why is it so? Because work is done on it against gravity while we raise it high up in the sky. So when we are raising it, what is happening? Work has been done on that. And why the work has been done? Because the work is done against the gravity, right? When we are raising it, it's going opposite to gravity, because of which we can say work has been done. So the energy which is present in such an object is the gravitational potential energy. Which energies will be present in that object? The energy present in that object will be gravitational potential energy. So the gravitational potential energy of an object at a point above the ground, okay, it's above the ground. So we can define that as the work done in raising it from ground to the point against gravity. So can you see the ground in the picture? The work that has been done when you are raising this box to a certain height. So how do we define this gravitational potential energy? As work done in raising the object from ground to that point against gravity. That is called as the gravitational potential energy. Okay, and it is easy to arrive at an expression for the gravitational potential energy of an object at a height. So sorry. So I want you all to I hope you have understood this, and I want you all to write the definition for this gravitational potential energy and even draw the picture that has been shown, as both of it are very important, right? So I hope you all are writing it. So consider an object of mass m. Let it be raised through a height h from a ground. So the mass of the object is small m. The height that it has been raised to is considered to be as small h, and a force is required to do this, right? If you are lifting an object to a certain height, you need to apply force. So we need a force to raise that object from the ground, right? So the minimum force required to raise the object is equal to the weight of the object. Okay, what I said? The minimum force required to raise the object is equal to the weight of the object, that is mg. So it becomes force is equal to mass into gravitation, acceleration due to gravity, that is g. So the object gains energy which is equal to the work done on it. So how much work you will be doing on that object, that same amount of energy the object is going to gain. Okay, so let the work done on the object against gravity be w, and w is the capital, like work done, right? So work done, that is being represented as capital W, is equal to force into displacement. We know force is equal to mg. See, there are different formulas for force, ma then mg, right? It depends accordingly like what you are applying, because here we are discussing with respect to gravitation. Over here we have acceleration due to gravities. A and g, they both are equal. Okay, so over here we'll write force is equal to mg and displacement as h, because displacement is the height itself. So over here the displacement that we are taking is h. So over here the work done will be mgh. Okay, so since work done on the object is equal to mgh and energy equal to mgh unit is gained by the object. Okay, what I said, because the work done on the object is equal to mgh, there will be an energy, because there's one statement on the top that the force, like the work done on the object is equal to the energy the object will have, right? So work done on the object is equal to mgh. M is mass, g is acceleration due to gravity, h is displacement. Okay, so mgh and energy equal to mgh unit is gained by the object. So this is the potential energy which we represent as EP of the object, and we get the potential energy as mgh. Okay. I hope you all are writing this. I hope you all are writing it in your book. Okay, we'll complete this today. Once you are done with this, after this, see, it is useful to note that the work done by gravity, it depends on difference in the vertical heights of the initial and final positions of the object. What does it depends on? What is the difference that exists in the initial and the final position of the object? So let's say if it is on the ground, the initial position of the object is the ground, and when you take it to a certain height, the final position will be the height at which you take it to, right? So whatever differences there is in the initial and the final position of the object, the work done by the gravity depends on that itself. Okay, so figure 11.8 shows a case where a block is raised from position A to B. So can you see in the first figure we have like the block moving from A to B, and that is a straight path, and in second figure you can see the path is different, right? So it shows whether a block is raised from position A to B by taking two different paths. So let the height AB is equal to h. What is the height AB equal to? Small h, and in both the situations the work done on the object is going to be mgh, which we have already discussed, right? That potential energy is equal to mgh, right? So I want each one of you to please go through it quickly. You need to even draw the figure 11.8, so please make sure that you're writing it quickly. Now see, we have an example 11.5 which has been given. Find the energy possessed by an object of mass 10 kg when it is at a height of 6 meter above the ground and the given acceleration due to gravity is 9.8 meter per second square. Okay, so for this, mass of the object given is small m, height is h, that is 6 meters, and acceleration due to gravity is 9.8 meters, right? So from equation that we have the formula that potential energy is equal to mgh, right? M is 10, g is 9.8, and h, that is height, is equal, displacement is equal to 6. So when you multiply this, you'll get the answer as 588 joule, that is 588 joule. Okay, so this is how you will be calculating the potential energy. It's just that you need to know how to use the formula. Okay, so I just want you all to please quickly have a glance through it as well. Then after this we have one more example. See, an object of mass 12 is at a certain height above the ground. If the potential energy of the object is 480 joule, find the height at which the object is with respect to the ground, and given acceleration due to gravity is 10 meter per second square. Okay, so the solution is, you know the mass, you know the potential energy, right? So you are going to apply the formula for potential energy, which is equal to mgh, and accordingly you are going to calculate the height. Okay, so the calculation part has been given. I want you all to please go through it quickly. So after this we have the other thing to discuss, that various forms of energy, are they interconvertible or not. So I'm going to start with this in the next part, but make sure you all revise whatever we have studied. So after this we have activity 11.4 that we will be discussing on. Then we have law of conservation of energy to discuss. Okay, after the law of conservation of energy we have activity 11.15. Then we have rate of doing work. Okay, we'll be discussing on that. Then we have activity 11.6 in detail. Okay, we'll be studying on that. Then we have example 11.7 to discuss. We'll be even discussing on that. Then after that we have this example 11.8 to discuss in detail. We'll be discussing this as well. Okay, then we have commercial unit of energy to discuss, right? So we'll discuss on this, and this is going to be the last part for the lesson. After this we have the summary discussion, right? So we'll be doing that as well. And then we have 21 exercise questions to discuss. So I'm going to show you the questions one by one, and I want you all to please go through the questions so that it becomes easier for you when we start with it in the next class. So sorry. So this is how we will be ending up with this lesson, work and energy, right? So before we start with it, I want each one of you, like before I start with the next part, make sure you all revise whatever we have studied so far in the lesson, because you revising each and everything is very important. That is going to give you a different kind of confidence. Okay, so make sure that whatever we did today in the part with respect to potential energy, we are done with potential energy today as today. So now we will be starting with the further part. Okay, but make sure you're clear with all the previous topics that we have studied. I am ending this part over here. Thank you everyone.